When one of tomorrow's satellite launches, what kind of data are you most excited to get and what do you do with it? So I've had conversations about our first expert forecast was about our satellite launches and what it
Mhm.
takes to get up there. I had some really insightful conversations about the different types of data we get, but it would be amazing to understand as someone that is an atmospheric data scientist, like what are you excited to receive, especially with what we just discussed on the AI models and how we're ingesting all this new data. What's really exciting for you or the community? Yeah.
Yeah, I think the thing that I'm most excited for. So these microwave sensors that we take. I don't have you covered the difference between standard imagery and microwave imagery?
I think we might have a little bit, but it'd
Yeah.
be great for you to do a breakdown. I think it would be awesome to hear about it.
Yeah, so we've talked about microwave a little bit already, but so we're just talking. Yes, this is the microwave that your microwave in your kitchen operates at. But for our sounders, they're called sounders, is that we're not emitting at microwaves. We're just absorbing what microwaves come from the earth. So
Mhm.
every object, you and I, we all emit a spectrum of wavelengths of energy. And the hotter the object, the shorter the wavelength or higher the frequency uh, of energy that gives off. So the earth is warm, relatively warm, and it emits at a wavelength. We talk about one of the ones we're observing at. It's like 3 millimeters. So that's the
Mhm.
W band. So that's what maybe your pinky's 1 centimeter, so
Yeah.
much smaller than your pinky wavelength of energy.
Okay.
But we're taking pictures in that wavelength of the earth, and what happens is clouds and ice. So inside of clouds, you have small little water droplets and ice crystals, and those
Mhm.
ice crystals and water droplets can then scatter away the microwave emission. So if you imagine you're staring at a light and some little particle flies in front of the light, you can then see that particle in its shadow. So
Mm.
similarly, with our microwave observations from space, we're looking at some of these shadows from clouds and thunderstorms getting in the way of the microwave emission of the Earth.
Wow. So,
So
so
what
interesting.
makes me excited about our satellites is this idea that these microwave sensors are actually more sensitive to precipitation. And so I come from a background of doing a lot of precipitation research throughout my career. So that's something I get excited about. And the really unlocking potential, especially on a global scale, is this hourly update of precipitation globally. So you can imagine, in places over the US, we were talking about those golf balls earlier. The US spends lots of money having these surveillance radars on all the time. So we have a good understanding of where thunderstorms, snow, where that's all occurring at a good clip around the United States. But imagine you're out over the ocean, you have a big ship like full of freight that you're shipping from the US to Europe
Yeah.
or whoever knows. There's no radars out over the ocean, right? There's nowhere to put them. They have to be on something. So
Yeah.
our next best guess at precipitation would be maybe just take your iPhone pictures from space, but then you only see the top of the cloud. So that's
Yeah.
kind of the hard part, where these microwaves can actually probe through the cloud and see, hey, how much is there? A lot of rain here? Is there some hail? We can see those types of things from the microwave signals. So
Yeah.
that's what makes me excited, and what I actually do with it in terms of for work here at Tomorrow. We were talking about ingesting it into the weather forecast, so I've been building it that way. But something also that we've been starting to look into recently has been more of the hurricane side of things, and
Yeah.
using the microwave imagery for hurricanes to learn how those hurricanes are strengthening, weakening, all that fun stuff.
Yeah. Those our hurricane images are pretty amazing with from our satellites. Yeah, I think it's really interesting and something that I learned joining tomorrow and a lot of people don't know is just like the gap of weather knowledge over the
Mm-hmm.
ocean. And our planet is mostly ocean and there's a lot of things, right? There's big ships, shipping crates,
Mm-hmm.
and there's lots of accidents that happen every year with them and that's millions of dollars lost, for
Yeah,
those
even if it's
businesses
just
that are
late,
relying on them.
even if it's just late by a couple of days,
Yes.
it's such a global integrated economy now that I mean, I personally get frustrated when my packages are late too. So
Yeah.
Gotten so
And
used to quick deliveries that if your freight hauler is late by a few days, then it goes late through customs, and then yeah, you
right,
just
through everything. And that
economic
was, I
loss.
remember, such a big deal, back in, 2020. We really everyone kind of actually had an understanding for the first time,
Hmm.
the how things
Supply
move
chain stuff, yeah.
globally. Yeah, and supply chains. And it was like such a, I never thought about it until then, and when everything was delayed, because when one thing delays, everything else does. And it's this,
Hmm.
it's a overall a massive cost in so many ways, like you were saying. But yeah, it was really fascinating to learn joining. And I think the average person does not know that we just do not, well, not now we're starting to provide that tomorrow,
Hmm.
but for the longest time, we really didn't have real weather information over the ocean, which is
Hmm.
a large part of the planet, and that we all have to, navigate, for whatever reason, getting our Amazon package or taking a flight or whatever it is, going on a cruise,
Yeah.
all those things. It's important. So that's really helpful, and I think a really great way to explain why it's important.